Hello guys, assalamu alaikum. Welcome back in my channel. And today we will be talking about system software and application software. This video is going to be very interesting and very important for you because in this video we will be talking about in details all the operating system, viruses, and all types of IDE, everything related to the software. Either it's a system software and the application software. So keep watching this video and try to watch it at the end so you never miss anything in related to the softwares. So the first question is, what is system software? System software basically provides the services that the computer requires. All types of services, including operating system and utility services. It allows instructions to be processed by the CPU to allow words processing software to process. Without system software, our systems cannot do anything. It will become useless, right? And software made up of two core elements, and the first one is operating system and the utility softwares. Operating system. Operating system is as a software designed to run other programs on a computer. Means all types of programs needs this operating system to be run effectively. It is considered the backbone of computer, managing both software and hardware resources. Operating systems is responsible for everything from the control and allocation of memory to recognizing input from external devices and transmitting output to computer displays. They also manage files on computer hard drives and control peripherals like printer, scanner, flash drives, USBs, and the most commonly known as operating system examples Windows, Mac, Linux, Unix, and Raspberry Pi, and a lot of others as well. Utility software is another type of a system software application. It performs specific tasks related to the computer function, resources, files, and security. They help to configure the system, analyze how it is working, and optimize it to improve its efficiency. Some of these utilities include utilities, disk organization utilities, data compression, file backup utilities. So it's basically related to some specific task. Then we have security utilities. We have three things in a security utilities. Actually, it's quite a lot, but I have mentioned three things. Antiviruses. Antiviruses will scan the computer system and ensure that files are quarantined so that they can be removed by the user. Encryption uses an algorithm to scramble. Scrambles means encrypt a file according to the key which is used to make the file unreadable. The key is needed to decrypt the file back to its original form so it can be read. Firewall monitors network traffic and blocks unauthorized access. Criteria is set, and if the data meets the criteria, it is accepted, otherwise, it is rejected. Disk organization utilities. It's going to be used to clean up the tools and disk defragmentations. System cleanup tools help us to search for and remove files no longer needed to reduce speed and speed up access to the system. Disk defragmentation tools is used to rearrange the parts of file on the computer drive. When a file is saved to the disk, part of the file might be saved in other different areas of the disk. These tools try to remove all the parts to the same area for quicker access. Quicker access. As you can see, the disk has been file can be arranged in different areas, but it will be arranged according to disk defragmentation for quicker access like this. Disk compression utilities. These softwares basically help us to make files smaller so that they take up less storage space and can be transmitted to others users more easily. File backup utilities. It's helpful to make the full backup and incremental backup. Full backup store all files and softwares on the system. Incremental backup only backup the files and software that have been added since the last backup. Next, this that was all about system software. Now we are going to learn about the application software. And application software is designed to carry out a specific task the user would need for completing a variety of tasks. These are the applications that the operating system would process and allow end users to complete their vital day-to-day tasks. There are most commonly used examples of application software: word processing software, spreadsheet software, presentation software, multimedia software, and web browsers. The first is word processing softwares. This allows user to create written documents, letter, reports, applications, anything. We can use MS PowerPoint, Word for this purpose. Spreadsheet software allows users to perform numerical calculations and functions to create automation for all mathematical elements. We can use Excel for this purpose and it will help us in different ways, for example, budgeting, accounting, stock counts, etc. The third tool is presentation tool. It will help us to allow users to create interactive and multimedia presentation to show to an audience. We can use PowerPoints for this purpose, and it will help us in different ways like sales pitches, launching of product, or making interactive slides for our students. Fourth is multimedia software. This helps us to use to create multimedia and interactive content for a number of purposes. Like it explores text, audio, images, video, sounds, and animation, and we can use a lot of different softwares to use this. We can use Adobe Photoshop, we can use Filmora, InShot, and a lot of other softwares as well for image manipulation, editing video, and a lot of other things. The fifth is web browsers. It's the most commonly used. It allows the user to access the internet and use the World Wide Web for their for their different purposes, like to research information, to watch videos, and to play. There are three ways to distribute something. Distribute these application softwares: freeware, shareware, and free softwares. Freeware. Freeware is basically the user when the user is not allowed to access the source code, so they cannot tailor the software to their need or fix any bug in it. The software is still covered by copyright, and the user must get the owner's permission to do anything beyond using it. So, freeware is means we can use the software, but we cannot edit it. But in the other hand, shareware is where users can access the source code. It means they can tailor the software to their needs and fix any bug in it. And if they want to do some changings in it, they can do it. The source code could be studied for educational purposes. The user can redistribute the software, but this must be done under the same term as the original software. The third one is free software. It gives a trial version of the software for a limited time with limited feature free of charge. It requires the user has to pay fee if the full version is required. It's also protected by copyright and is a type of a software license. So there is a difference between three free terms: freeware, shareware, and free software, which we can use to distribute these applications of. When we are distributing our software, we have to consider something, and it's basically the ethical responsibility ours when we are distributing software, and it includes accessibility of the software. It should be age appropriate, copyright, distribution of malware, environmental impact of distribution media, following guidelines of professional bodies, intellectual property thefts, offensive material should not be shared. We should not plagiarize some others' content of some other person's, privacy of data, and security of the software. And there are a lot of other responsibilities we should consider, and these are the most important. Want you to tell. I want you to tell. I want to tell you actually. Next is the operating system, the most important part of our system. Without this operating system, our system cannot work, application cannot work. So, what does the operating system do? Operating system will help us in a lot of ways. It's managing file, it handle interrupts, it provides an interface, it manage peripherals and drivers, it manage memory, it manage multitasking, it provides a platform for running application and system security and user accounts. In fact, everything is managed by the operating system in our system. Without operating system, our computer or this monitor is useless. So, one by one, we will be talking about all the things the operating system is responsible for. First is managing file. The file manager controls all of the different files on the system. For example, text file, graphic files, and program file. It controls file permissions such as the user ability to see, open a file, write a file, delete it. It helps to organize and control files so that they can they are as easy to use as possible for the user. It can help to protect the user from accidental mistakes too. Handling interrupts. So, an interrupt, basically, first we should know what is interrupt. So, interrupt is a signal from a device or a software to the process. It can be, this will be include to stop the processor temporarily or to do execution of another thing, right? From filling this required request immediately. Some examples could be software errors. Maybe there is some software errors where files not found or a software not responding. There's user initiated control or delete to log off the system. File stop copying as the name of the file is already in the folder. Once this interrupt is received by the CPU, it is either carries on or complete the action desired. Whenever an interrupt is initiated, the status of this task is saved to the interrupt service routine. Once the interruption has been completed, the system continues back to normal before the interruption even happened. Okay, that's it. So the third point is providing an interface. Interface is basically where we are acting something, we are selecting something. Whatever we see on the system, that's interface. So operating system is responsible for providing interface. User must interact with the operating system through a user interface. The user interface is a system which converts that user inputs to form that computer can understand and vice versa. Many computers or databases operating system uses complex programming languages which are not easy to use. As user interface is created to allow easier control of the operating system by the system user. A good interface should be easy to use. For example, consistent menu structure, consistent operation from action like clicking the right mouse button, clicking the left click, or so on. Managing memory is also done by the operating system. Memory management is basically the in charge of the RAM. Programs uses RAM throughout their operation. Some programs will be large and complex and use the RAM extensively, whereas some are very small programs and won't use it as much. So memory manager is going to check all the requests from programs are valid and allocate accordingly. It will deallocate space and swap out data to virtual memory. It will ensure overall that different programs can be open at the same time and can work effectively. This all process has been done through the operating system by using memory management. Manage multitasking. Multitasking basically allows us for software tasks to be completed at the same time. Means multiple tasks to be completed for the same time to ensure multiple elements can be completed immediately. It uses a system called time slicing, which splits different tasks into small segments. They can all be run one after the other, giving the element of multiple tasks being completed at the same time. Instead of waiting for once one operation to complete before moving into the next task. Providing a platform for running application. Application program and the hardware will communicate through a system within the operating system called an application program interface called API. API is basically responsible to work effectively hardware and software. This API is a library interface which will share data between software to allow elements to process. If an application is installed on the system, the operating system will manage this process. It will allocate memory space and will control the application's data or devices. User access will also be managed. Operating system is also responsible for providing a system security. System security is just about how the operating system can stay protected and ensure that elements are monitored and action to ensure the system is secure. Some areas of securities are creating or deleting user for the system, providing access level right, for example, administrator right over installing, modifying a system or accessing files or folder. This is compared to standard rights of just accessing and using system files on the system. Auditing, this is keep a log of file edits, deleted files, creation of file, etc. And another thing we can do for providing a system security is protection from threat using viruses, worms, threats, viruses, worms, malware, or remote hackers attacks. Security updates to fix patches in the operating system. Managing user access is also helpful for us by the operating system. Each user is provided with an account for access to the system. They will be provided with their username and then will need to create a password based on rules set out initially. Each account will then be granted different levels of access dependent on needs and level of security. This will also monitor login activities and even log users out if they have been inactive for a while. So there are three things: hardware, firmware, and the operating system. And they actually work together to create an effective thing. It actually ensures you have to understand how the four areas work together. In an exam question would focus on how these four key areas would communicate. So see, first there is an application software. You can see this is your application software. For whenever you will interact through application software through a user interface, the command will be given to operating system. Operating system will find out BIOS on bootloader, and this will be instruction through this will be given to the hardware, and hardware will follow the instruction and will give the signals to the firmware again send the signals to the operating system, and then at the result of that application software has been opened or whatever we want to do will be happened in the application software. So in this way all those four things are working together. Application software will communicate with the operating system, and application software will never ever be communicate with the hardware directly. Same goes with the hardware to the application. So there is always a bridge between application software and a hardware, which is operating system. Firmware, this process is in between the operating system and a hardware. When a computer initially first load up, it has to explore the ROM for its initial boot up instruction. These are contained in a bootstrap loader. The initial process is handheld by the basic input output system, which is known as firmware. This will provide some low level control for all devices. Once complete, these are sent to RAM to be processed by the operating system. Overall, this creates an extra layer which is to ensure that initially the hardware devices, for example, keyboards, are available and can be communicated directly with the operating system. So firmware is responsible for bootstrap loader. It's helpful to in BIOS handling interrupts. We have already talked about the interrupts. It's basically the signals from the CPU to the system. We know that computers uses a fetch, decode, execute cycle within the CPU to run instruction over and over. However, while this is occurring, other devices may need to signal to the CPU to tell it to stop temporarily so that it can do the dedicated specific task. So this has been achieved through the interrupts. For example, a user has initiated Control Alt Delete to run Task Manager, or a user wants a document printing. So interrupts will need to ensure that CPU can stop executing its current program to run code for the overall instruction interruption. Interrupts need to be added to an area called the interrupt service routine. There are two types of interrupts: hardware interrupts and software interrupts. Hardware interrupts is caused by a hardware device, such as hardware failure, let's say, for example, pressing a key on the keyboard, moving the mouse. And software interrupts will be caused when an application stop or request services from the operating system. For example, a program is not responding, a number is divided by a zero, and two processes trying to access the same memory location. So then the software interrupts will be called. Then it comes the registers. We have registers in our CPU to manage instructions. There are multiple types of registers: program counter, current instruction register, memory register, address register, and memory data register. Program counter is basically responsible for program counter. At the location of next instruction, which will need to be fetched, is stored in program counter. Current instruction register hold the current instruction being executed. Memory address register stores the location of where the data is being stored in RAM and where in RAM the data will be sent. Memory data register will store your actual data from the location in the RAM or that will be sent to RAM. So these are four basic registers and CPU, and it's as you can see from this picture. And this is your memory unit, and there is your program counter, instruction register, memory address register, and accumulator register. And this is your CPU's two part: control unit and ALU. And there are three buses which will help us to communicate through memory to CPU. Next, the interrupt service routine is simply added to the particular area where a certain set of instructions are sent that will need to be fetched, decode, executed to complete the command of the interrupt. As a result, it is clear that the current register will need to be changed at this point to accommodate the interrupt. The interrupt will be executed instead of original instruction. And when the interrupt is received, the current value that were held in the registers are copied back to the RAM and in area known as stack. These values are pushed onto the stack and are added to the top of the stack frame, which will save them for later retrieval when the interrupt is complete. There is a possibility that an interrupt can also be interrupted, which is known as division by zero. Due to the system in RAM, which stack frame, the current interrupt would be moved to the bottom of stack frame to complete the main interrupt initially. So the main point is that whenever there is an interrupt, we computer CPU will be hold all the instruction, and for first it will be execute the interrupt. And if there is another interrupt being called on an interrupt, so first we will again give the priority of the another interrupt or the second interrupt. So we will hold back the previous interrupt to the stack frame. Okay. So I hope you know that how much interrupt is important in our computer system. Next is comes interrupt priorities for different categories. So first we have a hardware, user, software, timer, input output devices. So if there is a hardware, so it can be power supply may have failed and power button may have been pressed. As far as user is concerned, so it's about moving the mouse, clicking an icon to open a new program, or a keyboard press. And for a software, it can be illegal instruction encountered, overflow, login request, crashing some files or a software. And for a timer, it can be that data logging program which reads senior sensors continuously and screen recording application. And as far as input output devices are concerned, so it can be a signaling of data transfer has been completed, printer ink supplied notification, and input devices may not be responding. Then it comes difference between high and low level languages. High level and low level languages. First, let's just talk about the low level language. Low level languages are languages that sit close to a computer's instruction set. These are basic instructions that the CPU will understand. It's closely related to close to the machine language. For instance, an assembly language which allows programmers to focus on programming simple commands, which in turn is converted into machine code. This element is needed for the core hardware to be able to work with the software. And low level languages are written for a specific processor to ensure they embed the correct machine architecture. Assembly language, we have already talked about assembly language in our other video, and here let's just have a quick recap. Assembly language is written using mnemonics. Mnemonics means abbreviated text commands such as LDA means load, STO means store. Using this language, programmers can write human readable programs that correspond almost exactly to machine code. Machine code is at the hardware level and is written in only binary 0 and 1s. High level languages. High level languages are computer programming languages which is easy to understandable by humans, and it can be in English like statements which allows user to program with easy to use code. It allows for clear debugging, and once programs are created they become easier to maintain because it's easy to understand for the humans. High level languages were needed more due to the development of processor speed and memory capacity increase. There are a lot of other high level languages used today: Python, C Sharp, Java, C++, and a lot of other languages. High level languages advantages and disadvantages. First, it's easy to read and write, and the programmer is less likely to make mistakes. High level language is easier to debug, so it will save time. The code is portable, so we can use on any computer. One line of code can perform multiple commands. On the other hand, the disadvantages are the user is not able to directly manipulate the hardware. It needs to be translated to machine code before running. The program may be less efficient. Next, assembly language. Assembly language is the first language where actually direct machine language, where programmers had to program it with direct binary numbers of ones and zeros. It was quite clear to you see that this method was incredibly difficult to program, which allowed the instruction of assembly language. Programmers who uses assembly language do so for the following reason. It needs to make use of specific hardware or part of the hardware to complete specific machine dependent instruction, to ensure that too much space is not taken up in RAM, to ensure code can completed much faster. Mnemonics. Assembly language allows programmer to program with mnemonics. For example, LDA means load. This will ensure a value is added to the accumulator register. Add addition. This will add the value input or load from memory to the value in the accumulator. STO means store. It will store the value in the accumulator in RAM. This is used rather than binary code, which allows continuation of working directly with the hardware but removed an element of complexity. A mnemonics is received by the computer and it is looked up within a specific table. An assembler is needed here to check the word so that it can be converted into machine code. If a machine from the word is found, for example STO, the word is replaced with the relevant binary code to match that sequence. Assembly language advantages and disadvantages. Assembly language gives programmers complete control over the system components so it can control hardware components. Its efficient code can be written for the processor so it will occupy less memory and execute faster. It also provides direct manipulation of hardware, which means it will be more efficient. It will communicate directly with the hardware. On the other hand, there are some disadvantages of assembly language as well. It's difficult to write and understand because it's near to machine language, machine dependent, and cannot be added to different specific machines. More prone to errors, and knowledge of computer architecture is key to program effectively in assembly language. Next, let's just talk about translators because we have talked about the high level language and machine level languages. So, we need some translator to translate the instruction from high level language to the level language to smoothly execution. Compiler and interpreter. Programmers will write program source code, matlab whatever programmer will write on the any software, that code will called as source code. Okay, using high level language. Python, Java, C Sharp. As a programmer, we can understand source code as it is descriptive, easy to read, maintain, and debug. However, it's not good for the hardware as it needs to be converted into binary to allow the hardware to understand execute it. This is known as machine code. For this to work, it needs to pass through a translator first. There are two types of translator, compiler and interpreter. Compiler. Compiler will run quickly as the program as the source code has been stored to the translated. Compiler optimize the code. This code will run quicker and take up less memory space. Compiler will Original source code will not be seen, which is ideal for programmers to stop work being copied. And there are some disadvantages. Due to all code being compiled at the same time, there must be enough memory space to handle this. If not, and virtual memory is used, it can be much slower. If there are errors in the code, the compiler will not identify directly where the errors lie, making it difficult to debug. Compiler it's designed solely for one specific processor. Compiler, if the program is changed, it must be recompiled. So, this method will translate a program into machine code. Compiler converts the source code into one go into an executable file ready for the instruction. This method is used mainly when a program is finished with no syntax or logical error. Compiler may take time to be processed, however, this can be used over without needing to be recompiled every time, bearing in mind that the program contains no error. Error reports are produced after a program has been translated. Common errors in code will allow the computer to crash and not respond. It's important to be aware that if there are errors, the source code must be changed to compile again. So, there are some advantages and disadvantages of using interpreter as well. Interpreter means program will always run. It will just stop when it's find a specific syntax error in the code. It's easier to debug and understand where particular code has gone wrong. Interpreter do not store instruction and are not stored for later use. This means they require less RAM to process the code. Program will always run, it will just stop when it finds a specific syntax error in the code. On the other hand, there are some disadvantages as well. Each line of code has to be interpreted separately by the CPU, which can lead to slower execution. Every time the program is run, it has to be translated due to no instruction being stored. They cannot optimize code, it is translated and executed as it is. Each line of code has to be interpreted separately by the CPU, which can lead to slower execution. So, interpreter is the method that directly sends the source code to the machine code. This will translate each line of code. This will translate each line of code individually. If an error occurs, the program will stop and an error message will occur. Once the error message is fixed, the program carry on running from where the error occurred. Okay, so next we are going to talk about IDE, Integrated Development Environments, how it's going to be helpful in our software development and how it's going to be more efficient, how it's going to be improve our product. IDE, an integrated development learning environment, is a software that consolidates basic tools required to write and test software to make a programmer's journey effective and useful. This will ensure that they have key features to improve programming code and ensure it does as instructed. Some features are basic codes, colored keywords in source code, code editing, commenting code, identifying errors, runtime environments, debugger libraries, and graphical user interface builder. Basic code formatting, it means we can change the font size, style, and color of font, making text bold, etc. Colored keyword in source code, for example, Python code print, input, whatever the keywords we are using in our code, this will make it easy to use keywords. And code editing, this will allows user to write and manipulate source code. It includes features such as auto completion, auto correction, bracket matching, syntax checks, etc. Commenting codes, this will allow sections of code to be commented out easily to stop it from being run or as comments on what the program is doing. Identifying errors, highlight particular areas of code or provide direct error message where the errors may have appeared. For example, indentation error, some syntax error, etc. Runtime environments. This allows the program to run and see if its corresponding output. Debugger. This will identify and remedy errors within the source code. This can provide a step-through commands also which provides step-by-step instructions and shows what is happening to the code line by line. This method is amazing for catching logical errors. Libraries. It provides extra modules that are not included in the main programming language, for example, math in Python for extra mathematical commands. Graphical user interface builder will create a graphical design rather than working with the source code. Translator. It will compiles or interprets the code. That's all for softwares, system software and application software. We saw different application. We saw how the application software, operating system software work together to make our system and make to increase our productivity. If you have any question, please do comment in the comment section box. I'll be happy to answer your question. So that's it for today. See you tomorrow in our next coming videos. Do subscribe on the channel. Take care. Love.